Hello, welcome to the Groundwater Hydrology course. I'm Thomas Sorens. I'll be your guide for the next few weeks. We're going to learn about groundwater hydrology. If I pump this well here, will I get water out? How much water will I get out? What determines how much water I get? How fast it goes? What happens down there under the ground? What happens to the water table? How fast does the water go? If there's some pollution up there, some contamination gets into the groundwater, is it going to make it down to this well? Will the water be clean? What determines how fast it goes and how much gets there? So we're going to be exploring these topics, these questions over the next few weeks. I'm glad you're along. And now I'm going to go back to the office and walk you through the course. Thanks.
Welcome to the Groundwater Hydrology course. I'm Thomas Sorens. I've been teaching for the University of Arkansas for about 3 decades now. First half of that as an on-campus professor in the Department of Civil Engineering in Fayetteville there. The last half teaching remotely. Currently my day job is I'm a groundwater remediation engineer, primarily concerned with the risk assessment part of the process. So this video is to walk you through the course, tell you some details of it. The course notes and everything is available on Blackboard. The videos are integrated in there, and they're also housed on my YouTube channel, Thomas S. UA. There is a text for the book from Uliana, Basic Hydrology, Introduction to the Fundamentals of Groundwater Science. That's available free online through the Groundwater Project. I've also put a PDF of it on Blackboard. But the Groundwater Project is a great resource for information books on groundwater. I encourage you to use it. There's another book I like a lot that I've used a lot in the past, Groundwater Contamination, Transport, and Remediation by Phil Bedient and others. That's out of print now, but if you can get a copy for $5 online or something, I'd encourage you, but you don't need it. That book is really good on the contamination hydrology part of groundwater, but there is a chapter or so on that in the Uliana text, and there are other whole books on that on the Groundwater Project. So you don't really need it, but I thought I'd put that out there. The general objectives of the course are to learn the principles of groundwater flow, subsurface transport and fate processes, and their application to remediation technologies. So what makes this a little different from other groundwater courses is we do cover the basics of groundwater, but then the last about third of the course is on what we call contaminant hydrology, or the movement of chemicals in the groundwater. As I said, I work as a remediation engineer, and in my opinion, in my experience, that type of knowledge is really important if you're going to be working with anything with groundwater pollution. For the grading of the course, 40% of it will be homework assignments and exercises. There are 6 homework assignments, and there'll be 2 or 3 exercises where you just fill in the notes, just kind of keep you on pace on the notes. There'll be 3 exams, 150 points each. Those will be explained more in the Blackboard site. We would like you to get a proctor for those. I can proctor it for you via Zoom, or you can arrange your own proctor, or we have some other ways to do it. So let me know ahead of time if you want to do that. There is a term paper that's 15% of the course. Look down here, it's just anything on a groundwater topic, and here's some examples of one. So you can interact with me on coming up with a topic, and I can give you some feedback on whether that's good or not. The university asked us to put in a statement on our expectations in artificial intelligence. You can use it you want for the writing. Don't just give it a topic and tell it to make the paper. I want you to learn through that. Please don't use it for calculation assignments. I've actually assigned students before in a different class to use AI, and it's pretty bad at some of the calculations. There'll be 3 exams. Each exam is allowed 2 hours. The first one on Darcy's Law and quantities. It's going to be closed book, closed notes. The reference material you'll get is provided for you. On each of these also give you a study guide for it. Exam 2 is open book, open notes on aquifer tests, and exam 3 is on the transport and fate processes, contaminant hydrology. Here is the course structure and schedule organized by week. I'll also have for each course, you'll have a schedule with dates on it. This schedule and the associated due dates will get you through the course in plenty of time in 8 weeks. The due dates are kind of soft due dates. I understand everybody has different schedules and you can hit it hard for a while, then you got to back off for a while. But this will get you through again in 8 weeks. The numbers in this column are the videos. Each video is between 10 and 20 minutes about. Then I also give the reference for where it is in the text. And then the different homework and exercises, their due dates are listed here on what day they fall in the 8-week session. The course is front loaded with material, so you can, last week or so, you can just work on your paper or catch up if you've fallen behind the recommended schedule. The specific objectives relate to Darcy's law, which is the fundamental equation of groundwater flow, the properties, including the porosity and bulk density of the subsurface, steady state well equations, the use of image wells, the 3 different aquifer test methods, the Tice method, Cooper-Jacob method, and the slug test method. And then in the contaminant hydrology conceptual model, understanding the different fundamental processes that govern the fate and transport of the chemicals in it. And then finally, some on the remediation technologies. Take you now to the Blackboard site, which if you're watching this video, you've probably found already. So we have some information that this video I'll put under this Welcome to Groundwater Hydrology section. We have the syllabus, a schedule for your specific session that you're in, and some information on the textbook, some more information on me. For navigating the course, you'll want to go to weekly lessons. And it's organized pretty much by week, with some weeks spilling over into the next. So week 1, for example, we have the lesson, which is an outline. Tells you what's there. The files you'll need for that week, including the notes, will be there. So the groundwater notes, and I try to provide everything in both a Word document and PDF. So you want to download those, and then there are places to fill in as you go, either on paper or if you want to do it on your computer, you can do it that way. And then the other files that you need for the homework for that week. Listed over here are the lectures, and so you can follow along there. And again, those are clickable here, and then also you notice those are housed on YouTube. So each week we'll walk you through, and then there'll be a couple of maybe an assignment or two. This first one is, again, just fill out part of the note to go through. The second one is a homework assignment. This particular one, I have a video that walking you through the homework assignment. So you will fill that out and submit it, and then I will grade it and get back to you. And I have the solutions handy, so I can send you the solution after you submit it. Which, by the way, back to the notes, I do provide you with a PDF of my notes that I've done during the video if you want to go back and check those. It works that way for the other weeks as well. Week 2, overview with an outline, the files that you need, and then the videos, and then assignment, which may or may not have a video explanation in it. For example, the finite difference assignment, it doesn't have a video because the video for that's integrated into these. Week 3 is the first time you get an exam, so the exams are actually integrated into the weeks. So you'll click on there, and it has a due date there. And again, those are soft due dates, but you can set up a time for me to proctor, or you can get it proctored on your own and submit it there. So this, you're looking at my version of it. Your version might have a little different look to it, the student version, and then also I might make a few changes before I get there, but I think it's pretty much set now. So this is what the course will look like. I'm looking forward to working with you. I want to say one more time that I'm available all the time. If you have any questions or need any feedback or interaction, let me know. All right, see ya.